Hi, hello everyone. Welcome back to another video tutorial on data structures. In previous sessions, we discussed what is a data structure and we have seen few linear data structures like an array and linked list. And also we have discussed different types of linked list like singly linked list, doubly linked list and circularly linked list. Where in this session, we will be learning about the other kind of linear data structure that is stack. Coming to the learning outcomes, after taking this session, you will be able to explain the stack ATT and its representations in terms of an array and linked list. Where the other part of this session is you will be able to create and implement the stack ATT using an array. Coming to the definition of the stack, a stack is a last in first out data structure. In short, it is called as LIFO, where the insertions and deletions are allowed only from one end. That end is called as a top. A stack is a list which is nothing but the group of elements with the restriction that all the insertions and deletions can be performed from only one end. That end is called as top. Let us discuss the concept of the stack with a real world example. Consider the stack of books. Here I am taking 4 books which I am placing on a table one above the other. Like book 1, on top of book 1 I'll be placing book 2, on above book 3, on top of it book 4. Now if I want to remove any book, if I want to take out a book from the stack, which is obviously the last one, that is book number 4. After that, book number 3, followed by book 2, at the end, book 1, which I placed at the beginning. Isn't it? So we're coming to the other real world examples of a stack, like stack of plates, like a pile of CDs, and the pack of balls. But in all these examples, if I want to place any item or if I want to remove any item from these stack, it is obviously the top item. So which is, it follows the last in first out principle. That is, the element which I have placed last, the item which we have placed last onto the stack will be the one which will be removed first. Hence, it follows the LIFO principle, or in other terms, it is also called as the first in last out principle. So here, a stack can be called as LIFO, or it also called as FILO. By coming to the operations, the two fundamental operations that are allowed on stack are, one is push, which is used to insert an item into the stack. The other one is the pop, which is used to remove an item from the stack. Where the additional operations can also be performed on stack, like the traversal, which is used to display the contents of the stack, and with the typical operation like a peek, which is used to return the topmost element from the stack. Where the condition checking operations like isFill, which is used to check whether the stack is full or not, and another conditional operation like the empty, which is used to check whether the stack is empty or not. Let us discuss the implementation of the stack. A stack can be implemented in two ways. One is using an array, and a stack can also be implemented by using the linked list. Let us discuss the stack implementation using an array. Consider an empty stack of size 5, which can accommodate only 5 items, where this is the logical representation of the stack with the positions 0 to size -1, 0 to 5 -1. Where initially there are no elements in the stack, hence there is no top element on the stack. The top is -1. By coming to perform the push operations onto the stack, first I want to push an item 10 onto the stack. Where here, first increment the top to position 0, and at position 0, insert a data value 10. Now similarly, push other items onto the stack, like push 20 onto the stack. First increment top to the position 1, and at position 1, you insert 20. Now similarly, push 30 onto the stack, increment top to position 2, and at position 2, insert 30. Now similarly, push 40, where increment top to position 3, and at position 3, you push an item 40 onto the stack. Now push 50, where increment top to position 4, and at position 4 you insert 50. Now similarly, in the continuation of push operation, push 60, where top is already pointed to 4. If you increment top, that crosses the boundary of the stack. Hence, this condition is called as an overflow. If top is greater than or equal to size minus 1, then there is no empty location in the stack. That condition is called as an overflow condition, where here the pseudocode for the push operation is given as before performing any push operation onto the stack, let's check for the stack overflow condition. That is, if top is size minus 1, then you give an error message like the stack is full or stack is overflow, or otherwise you read a data item, increment the top pointer and push the item onto the stack. Now let us discuss the pop operation on the stack. And take the previous example where stack is full with 5 data values 10 to 50. On top we have the data value 50 and that is indexed by the top with the value 4. Now take out the top element and decrement the top. Now top is pointing to position number 3. Now if you invoke pop again on the same stack, take out the top element and decrement the top. Top will point to 2 now. After removing the top element, 40. Now similarly, invoke pop on the same stack. Now remove the top element from this stack, that is 30, and decrement the top. The top is pointing to now by 1. Now similarly, invoke pop on the same stack, that will remove 20, and decrement top. Top will point to 0 now. Now, if you invoke pop on the same stack, that will remove the top element, that is 10, and decrement the top is minus 1. So, where the top is coming back to the initial position, that is minus 1. Now, if you trying to perform the pop operation again, where top is minus 1, hence this condition gives the underflow error message. Like coming to the pseudocode, if top is, that means before performing any pop operation on the stack, first you need to check for the stack underflow condition. Like if top is minus 1, then no more the deletion operations are allowed on stack. Or otherwise, that is nothing but there are some elements in the stack, hence you can remove the elements from the stack like this. Take out the topmost element and decrement the top. Let us see the animated video of the working principle of the stack. Push 11 onto the stack and that will be pointed by the pointer top, and pushing 23 which is pointed by top, again minus 8 top, 16 that will be pointed by top, pushing 27 that will be top, push 14 that will become top, push 20 that will be the top now. Now coming to perform the pop operation. The top element is 20, that will be removed. Next 14 followed by 27, then 16, then top will point to minus 8, that will be removed. And pointing to 11, that will be removed from the stack. Now the stack is empty. Let me explain the traversal operation on stack. Consider a stack of 5 elements, and we know that the top element is accessed by using top. Now the top is pointing to position 4. So we'll be able to display the topmost element, that is 50. Next we'll decrement the position to 3 and we'll display 40. Then we'll decrement the position to 2 and display 30. Next we'll be decrementing the position and able to display 20. And at the end, decrement the position to 0 and display 10. So this is the procedure to display the contents of the stack from top to bottom, which is very useful when you want to display the list contents in reverse. Let us look at the pseudo code for the display operation on stack. So the traversal is from top to bottom, that is from top pointer to 0. And for each iteration, print the data item and decrement the pointer, that is I minus 1, till you reach I is 0. Now let us implement stack using an array. We take an empty file. Just give required header files, that is stdio.h for input for printf and scanf, and define the size of the stack like 5. And then I'll declare some global variables like top, which is taking as -1, which will set to -1, and a variable x to read the data item, and then some variable like I, the loop variable, and declare the functions like the push, the basic functions, stack, the pop, and the peek, which returns the topmost element, and then display. So we'll perform 4 operations on stack. Now here I'll take a choice variable 2 as a global variable. Now let us give the menu options like, one is the push, the second option is pop, the 3, that is peek, then 4, which is display. Now take a loop. Here read the choice. Just ask to enter choice. Read the choice variable. Then pass this choice to switch to invoke the corresponding function call, like case 1, which invokes push operation, and that case 2 that invokes pop, case 3 which is for peek, then case 4 that is display. So this will iterate for choice less than or equal to 4. Let's define each function. Coming to push operation, here first let me check for overflow condition, like if top is greater than or equal to size -1, then give the error condition like stack overflow. In this situation, it is not possible to insert item onto the stack. If there is any empty space, then you go with reading the data item, enter data, like read it in some variable, which is x. And then what we'll do is we'll increment top and then insert the data onto the stack. Suppose the stack is S, like S of top equal to X. First, you need to declare S before using it, which is S of size. Right. Let's implement pop. Here also, before doing the pop operation, first you need to check for underflow condition. If there are no contents in the stack, then it is no use to implement this pop operation. Hence, first check for the underflow condition. No element to pop. If there are any elements, then just take out the topmost element and then decrement top. Just peek. Here x equal to that S of top, the topmost element. Just print the top element like top element equal to X. Now the last operation, which is display, where equal to starting from the top element to the bottom element. Each time decrement the index and then print the value. So that's all with the implementations of stack. Let's see the execution of operations like push, insert the data item. I have inserted 10, 20, 30, the 40, and then 50. Now I am trying to insert 60, hence it is giving the stack overflow, the error condition. Now let's give the option like 4 to display all contents from top to bottom. Now we'll see the third operation, which is peek. It returns the top element as 50. Now we'll see about the pop operation like 2, and then give the display contents. You see here it is displaying 40, 30, 20, 10. And then give execute the option 2, that is pop operation. Now give display, which is 30, 20, 10. And again execute pop and then display, which is 20 and 10. Execute pop and display, that is 10. Execute pop, display. There are no contents. Now execute pop. You see here there are no elements in this stack, hence it is giving the error condition like there are no elements to pop. So that's all with the stack implementation using an array.